Alrighty. Did I click something? I don't see a picture here. All right, there we go. Oh, the old guy's tired, but I want to try to get part 2 done. And then I'll talk about limits, how to look at a graph, determine when it's greater than or less than some value, point to discontinuity. I think that'll be in part 3. I mean, right now, we're just going to fill in the rest of what the graph looks like. We've already established x-intercepts, y-intercepts, undefined situations, and end behavior. So now we're going to tackle what the rest of it looks like. And I think we can kind of see the pattern here. Okay. And we've got sign changes. These are both to the first power. So we've got sign changes, positive to negative to positive. With practice, you'll probably be able to do that in short term, but you can check it out. What's interesting? What's interesting is what's undefined. Is it 2? The heck, I put that there for, I have no idea. 2 is undefined. Suppose I'm tired. You get what you get. All right, so it would seem that you would want to plug in some numbers to verify what you're seeing. So how about we pick a number to the left of -3? How about we just pick -5, for instance, and find out if our number is bigger than 0 and in between 1 and 0. So we put -5. -5 minus 3 is -2. -5 minus 2 is -7. 2 7ths. So it would be a little lower than what I've got it, but yeah, I'm between 1 and 0 and it's equals. Let's pick a number over here that is less than 2. So I should label this x equals 2. All right, so how about we put 1 in? And let's see if 1 gives us a number that's less than -1.5. So we put 1 in. I get 4 over -1. Oh yeah, I get -4. So you got to take the time to do that with these functions. If you're not plugging numbers in and you're not performing the calculations, I don't know how you get a feel for any graph when you're trying to learn what you're looking at. You got to play with numbers. All right, so what's a really important number here? I think a number like 2.001. You gotta do it. You gotta put it in, and I'm gonna take my time with this one. 2.001 plus 3 divided by 2.001 minus 2. And I'm gonna get my eraser, and I'm gonna work with that calculation. Well, the first thing I see is, get rid of the 2's. And I can see that I have tenths, hundred thousandths. I'm dividing by 1 over 1,000. When you divide by 1 over 1,000, that's the same as multiplying by 1,000 over 1. All right, how would you describe a number like 5-ish times 1,000? I'd say it's pretty big. Oh yes, the closer I get to 2, the more zeros I can produce, and the bigger I get. Okay, now I was going to do that in part 3, but since I've really analyzed it here, I'm going to write what a mathematician would write to describe what we just did. And instead of calling this y2, I'm going to call it f of x. All right, so what is the limit of f of x? As x approaches 2 from the right. Because I could have put in 1.999. And if we did that, the only thing that would change is -0.001. Excuse me. Which means I'd be multiplying by -1,000, and that would be heading towards -infinity. Okay, but this one headed towards positive infinity. If I put a negative sign there, I would have been heading towards negative infinity. And if there was no sign there, then we say, you know what? I got no clue. I'm headed 2 different locations. I can't make my mind up. Can't be at 2 places at one time. Not quite sure how else to describe it. But when that happens, if you're not headed, you don't know your destination, and it does not exist. And you're going to have to get familiar with this notation. We got to start the conversation. We just started. Actually, we've been having that conversation for the last few weeks, but some of you have been ignoring me. All right, so is there anything else to check? Yeah, maybe we should check a big number. You know, let's just pick 10. Usually 10 is enough to get a feeling. Are we starting to head to the number? Are we going to get a number bigger than 1 in this instance? Let's put 10 in. 13 minus 13 divided by 8. You know, that's a little bigger than 1. I'm getting close. I'm getting close, you know. All right, so is there anything else to talk about? Yeah. When are you bigger than 1? When are you bigger than 0? Sorry, that's been a question, right? That I've been throwing your way quite often. And you've been doing what? You've been doing the number line for these because we've just started to learn how to graph these. So we've been putting the critical numbers here. And let's see if we can talk about, we know we just did one bigger than 2, 10. We just did, and we got an answer bigger than 1. So that's true, and we know it alternates. So let's see if we can spot it graphically. How would you describe all these y values? I think I described them as positive. So yes, those are bigger than 0. Right. All right, so that's an interval. But what happens as soon as I get on this side of 2? I get all of these y values, negative, 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 until I get to that x value. And once I get to that x value, the y values are positive. And what are y values coming from? Performing the calculation, right? When I perform -5, when I evaluated that number, I got a positive altitude. When I put in a number like 1, I got a negative. Remember, I think we got -4. Right? So, looking at the graph, I would not have to do the number line if I had the graph. I can see that I'm greater than 0 from -infinity to -3, union less than 0 from -3 to 2. So I pick it up again at 2 to infinity. Interval notation. There's the corroborating number line work. We talked a little bit about limits, talked a little bit about working with numbers, and let's do it again. We could pause the video and try to fill in all those things. All right, so we got a couple of undefined situations. -5 and 5, and we're going to get that crazy behavior again. When I pick 4.999 or I pick 5.001, right? I'm going to get a really small denominator that's going to fit into something that is approaching 5 minus 2, 3. Might be a little off, but I'm really close to 3 in the numerator, and I'm generating numbers like 0.001 or -0.001, which is going to fit into 3 lots of times. Okay, so let's get those asymptotes written now. X equals 5. This is not drawn to scale. 2 should be more this, okay, to the left. So let's just say that's x equals 5. And I hope that you can get a feeling for, if you put 5.01, the same thing happens as happened in the last problem. We're going to get a very big infinity generator. Closer I get to 5, the smaller this number. And when you multiply by the number over here, you know, you're just going to affect the last digit, really. And you're going to get one of those 0.0 situations. And I know that this thing goes to 0 because if you put a number in, let's go to something bigger than 5 this time. Let's put 100 in. 100 is much further down there. Let's just put it here so you can see it on camera. If I put 100 in, I got 98. 105 times 95. 105 times 95. I don't know what. All right, can we just say, for purposes, I got something with 5 digits. Okay, so let's just do that. I think you're getting close to 0. we did talk about it, I think, in the first video, the exponent in the denominator is bigger than the exponent in the numerator. I think we looked at the graphs and talked about x squared. I just very briefly bring us back. X squared is increasing faster than the linear function. And so we're eventually dividing by y values, and these y values eventually get so big. Talking to my 2-year-old twins. So big that the bigger this gets, the fewer times it's going to fit into something above it that isn't growing as quick. All right, so it goes to 0. So that gives us this. We got sign changes all everywhere, so I'm going to get a negative. So it's got to do this. And it crosses. Oh, yeah, I got to get the other asymptote in over here. X equals -5. All right, and we're going to verify if this is true. And that's what I think it is right now. If I find out I made a mistake by plugging some numbers in, I'll catch it. All right, and then I'm going to go to the negatives. How many sign changes? 1, 2, 3. So I'll have 4 positive, negative. Ooh, this could be tricky over here, but I have no more x-intercepts, so it's got to be this. It's got to be that. I only have 1 x-intercept. That's right here at 2, 0. So let's check out if -4, for instance, kicks out a positive y value. -4 minus 2. -6 minus 4 squared. 16 minus 25 minus 9. That's a positive value. So it looks like it, it stays lower much longer. Okay, I just realized that by doing a little work. Right? And let's see what happens over here. Let's see if I still get a negative number when I put in -10. Got to make sure I'm not making a mistake. I'm tired. I could make mistakes all over the place when I'm tired. I do. Seen my videos. -12. Oh, I picked -10. 175. Oh, thank goodness. Thank goodness. It's a small fraction. I feel okay about this. So I think I'm good. So let me pose a question. When am I greater than 0? You pause the video, look at the graph, and I'll tell you what I think it is. I need a little more space here. I think I'm starting at -5. Well, let's put it in parentheses. And I think I'm going to be, I think that's critical right there. That was 2. So -5 to 2, I believe, kicks out positives, but then you get a negative. So I got positive, negative, positive, negative. Well, I feel better now because I counted wrong once. So when do I pick up with positives again? Oh, over here. And that starts with x values of 5 and goes to infinity. And keep in mind, if I put an equal sign there, then we just put a little bracket, right? We've been doing that all semester. And if I said or equal to. Wait a minute, I made a mistake. Not 5, right? Can't use 5, so that stays as a parentheses. Good, I corrected it. So I'll pose a question. What's the limit? As x approaches, how about we do 5? And I'll use that symbol. We'll call this g of x. All right, so you look at the graph and see if you can pause it. Okay. Hope you said as I move in from the left. So going to 5 from the left is like saying I got 1, 2, 3, 4, 4.5, 4.9, 4.99999. Right? When I plug in a number like that, I'm going to get a pretty darn big negative number out. That's what you're trying to see. Okay, and I didn't show my nice 99999. Oh, will I get through this? Need a nap. So how about if I get rid of the minus sign? Say, well, what's the limit of that g of x as x goes to 5? I hope you say it doesn't exist from the conversation we had 5 minutes ago. DNE. I'm going to positive infinity as I decrease numbers towards 5, negative infinity when I increase numbers towards 5. That's not the same. It doesn't exist. Okay, so I guess we'll only have to make 2 videos because we're already talking about limits, talking about verifying the graphs, and we're talking about when it's greater than or equal to 0. So wonderful. So here's this fraction. We've been working with that. Hope you look at it and you go, oh, First power, again, same thing, sign changes there. At the critical numbers. All right, so I've got these two values here, and I'm heading to 2 from our first video. Sure looks like it's gonna do something like that. How do we verify it? Pause the video, think about that. I'll pick a number like 5. Will the y value come in less than 2 but positive? Let's find out. 20 minus 8. 12. Divided by 6. Oh, I picked a nice number. Whoa, that bothers me. 10, 11. Oh, thank you. I picked 5. Ugh, tired. 10 plus 1, 11. All right, yeah, that's bigger than, so that would have been right about here, right? So I'm climbing too quickly. But, all right, hopefully we see that. And then we know we're not crossing the x-axis anymore. And I'm heading to 2. It's got to do this. It's got to do that. All right, and negative 1/2 is where it's undefined. That's what makes the denominator 0. I'll call that negative 0.5. You take the time to put in negative 0.4999, some number like that. That's going to give us what? That's going to give us a positive or a negative number here. It's going to give us I believe, a positive. And if I put in negative 1/2-ish here, I'm near negative 10. I'm near negative 10. I've got a 0.001 kind of thing I'm creating, and it's negative, I think I said. Well, I should have been more careful with my work right now because I am tired. What am I picking? I'm picking minus 1/2, minus 8. Oh God, I'm not going to do the video again. I'm having one of those moments. So let's put negative 10 in real quick. Minus 48, so I can salvage this. Minus 10 plus 1, minus 20 plus 1, minus 19. All right, that's a little bit bigger than 2. So yes, so I'm a little bit higher than 2, so that's good. And I know it's, oh, I should have picked the number. I'm thinking about negative 4.99, giving me what it should have given me. What I had in my brain at the moment was negative 0.501. That's what I was thinking, because I'm tired. And yes, that's going to give us something that's heading towards positive infinity. So why would that be? This is near negative 5, so that's there. And if I put this number in, then that wouldn't have been positive. It's negative. And so hence we can see where we're headed there. All right, so what am I bigger than? Let's do 0 again. What am I bigger than 0? Well, certainly negative infinity to negative 1/2, which is undefined. Union what? We pick it up again at 2 to infinity. All right, and what's the limit? We call this h of x. This function h of x. Oh, God, I hope I get through this. As x goes to, well, you pick something. How about we say goes to 5? Huh, that's a little different situation. Well, we kind of just did that, right? I'm headed to the same value. So I'm trying to find that y value. Right? I guess I should color it in because it exists. Okay, so let's put 5 in. Is there any reason I can't? No. It's defined at 5, so we got 20 minus 8 over 11. 20 over 11. You know, what if I said, what is that as I head to negative 1/2? And let's do it from the left. What's that answer? Well, you've got to follow the graph from the left side. So minus 1/2, which is here. Looks like I'm going to infinity. As we already talked about. Hope I didn't hide the camera there. You can tell I'm. Oh, so. Okay. Yeah, I got to get this video up because the rest of the day I'm busy. All right, let's see. Take a little more time here. Slow down. No, I got to get out of here. But if I keep making mistakes, take me longer. All right, so now we got to factor this x squared minus 2x minus 10. X minus 5x plus 2, that's correct. Got to factor this, which is 2 times x squared minus 9. Difference of 2 squares. Hopefully you're able to do that. Practice it enough, that's for sure. All right, so what's undefined here? 5 and negative 2, so let's put that in. X equals 5, X equals -2 over here. Let's do that. All right, what do we think's happening if I put 1,000,000 in? If I put 1,000,000 in, positive, 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 I have no x-intercepts over here. My x-intercepts are at -3 and 3. There's 3, gets me a 0. I'm surprised this isn't already on there. -3 gets me a 0. Oh, that's over here. We don't want that, messing up the work. So -3 gets you a 0. It's certainly looking like it's shaping up to do this. It's shaping up to do this. I cannot cross again, so it must do that, and it's shaping up to do that. So I get a sign change at 3. Boom. Well, negative to positive, yes. And also negative to positive here. Sign change at 5. Yeah, negative to positive. Yeah, sign change at -2. There's -2. Here's -2. Positive, then negative. Yeah, so, okay, it's starting to look good. We can verify it with a number like 6. 6 had better get me a positive value bigger than 2. Easier to come here, I think. 72 minus 18, 62, 8, 64, I believe. And if I plug in what I plugged in a 6, yes, 36 minus 18. Interesting. 36 minus 18, 18 minus 10, 8. So I should get a 6 should get me 8. So this looks verified. I'll let you verify with some other numbers. Okay, I think, you can check to see if I made a mistake. And if I did, you let me know. I think you could pick -1. That would be nice to make sure you get a positive. You might want to pick 4. That's a nice one. See if you get a negative. Go ahead and do that. And when am I bigger than 0 here? Well, let's go from left to right. -infinity to -3. Union. Oh, -2 to the right gives me bigger than 0 from -2 to 3. And then I'm negative, but after 5, I'm positive again. So union 5 to infinity. Okay, and what's the limit? As x goes to -3. We'll call this p of x. I don't know, let's just call it p of x. This function, p of x. As x goes to -3 from that symbol. Yeah, I did write it so you could see it. I got lucky. I'll follow my finger from the left to -3. And I'm headed to, oh, well, that gives me 0. That's, I guess I meant to say -2. That's what I wanted to ask, but that other limit would have been 0 because -3 from the left goes to 0. It also goes from the right to 0. But let's do -2 from the left, -infinity. What is it from the right? Positive infinity. So what is it as I go to -2? Does not exist. So I hope I repeated that enough times that you got some practice with it. I got to upload this quickly because I got to get out of here in 10 minutes. So let me stop the video and hopefully put it on Canvas so that you can look at this tonight. And maybe by Thursday, you'll have it all down pat.